Hello guys, welcome to another video of Velvi. Last week we saw about strings, various operations of strings, various methods that we could do on strings. So now today I want to get into another really important data structure called a list. So let's get started, okay? So according to the Python documentation, the definition of list is Python knows a number of compound data used to group together other values. The most versatile is the list, which can be written as a list of comma-separated values, items between square brackets. List may contain items of different types, but usually the items all have the same type. Okay, so let's see what they really mean by that. So as they said, like list is just kind of like a collection of items, okay? So you could just think kind of like a stack of books, okay? So each book that you place in the stack is can be of different types, like one might be of a fictional type, one might be a history book, one might be a science. So of various types you could just stack together, right? So this is kind of like a intuitive concept of list. So here we have a list created of four items, okay? So you could see like each item is being separated by comma, and then here in this particular list all the items belong to the same type, integers, okay? But that need not be true all the time, okay? So just to give you a overall idea, list are item that are being enclosed in square brackets and the items are separated in comma. So simple, okay? So let's just execute this, okay? So list 1, 1, 2, 3, 4, and you have this, okay? So and then list, as we discussed, can of course obviously have any type, okay? So this is just an example of list of strings, okay? And then here is an example of list of mixed data type, okay? In this particular list, each item is of different type. So this one is an integer, this one is a float, this is a boolean, this is a string, okay? Still works fine. Let me just print that part. Okay, so clear, right? How to define a list. Okay, and then finally, how do you define an empty list? Let's say, for example, an empty integer is equivalent to 0, right? An empty string is just this one, right? And then an empty list is just represented by an empty square brackets. Okay, so simple. So I'll just do this. This will empty list. Okay, done. Okay, so the other way of creating a list, an empty list, is using the list keyword. Okay, what you just do is like we saw like int corresponds to an integer and then float corresponds to a float type. These are the keywords associated with those particular data types. Okay, and then for string it's str, and for list it's just list. Okay, and then you just call this. Okay, we will just see the intuition behind creating an empty list uh, through this particular method. Once we see classes and objects, we will have a better understanding, but I just want to tell this right away as well. So this again creates a empty list. Okay, so done. So we just saw like how to create list. Okay, and then like what are the items that we could have in a list. So quite simple, right? Lists. But the thing here is like most people get confused lists with arrays. Okay, so please make sure you understand the difference properly. Arrays are always of the same data type. Okay, so but a list can contain any data type. Here is an example for that. You saw here we have an integer, a float, a boolean, and a string. That isn't possible with respect to an array. Okay, array should definitely have all the items of the same data type. Please remember this. Okay, so this is the key difference between a list and an array. We will see more differences once we get started with arrays, but not the basic difference between an array and list. Okay, so having said that, so let's get started with the operations of list. So the operations that you're going to see in list are going to be kind of similar that we saw in strings. Okay, so let's get started. Okay, so let me define a simple list. Okay, a list 7967 Billie Jean true. Okay, and then the basic operation is the length operator. How do you find the length of a given list? You just use the length inbuilt function. We will see more about the inbuilt function later during this series, okay? But now just remember LDN of a given iterable or a sequence is going to return the length of that particular list or string, tuple or dictionary, which we are going to see later, okay? So LDN of list is going to give you 4. This is because LST, the list has 4 items, 1, 2, 3, and 4, okay? So now concatenation of lists. So concatenation works the same way as we do concatenation in strings using the plus operator. So as we saw in strings, apple, so it just concatenated both the strings, right? So similarly, LST plus another list will be the channel name, okay? So he's just gonna do the same thing. You could see like, okay, so you have this 1, 2, 3, 4 because it's kind of like I think there is a problem. Like you see, we are gonna this because of this particular operation. The 1, 2, 3, 4 is already being added to this particular list. So let me just quickly run all these comments above so that we want what we want. Okay. So let me check what we have on list. Okay, list is fine now. Okay, so LST plus Velvi is another list. So now both the lists have been concatenated together. Quite simple, right? So and then like we saw like when you multiply a string with a number, specifically an integer, the string kind of like just repeats itself, right? So the same thing is going to happen with list as well. Let me just show you with strings as well, just to kind of like you could compare these two to get a better understanding. So apple multiplied by 2 gives me apple apple. So now this particular list multiplied by 2 is going to give me 7967 Billie Jean True, and the same thing is being repeated again. So if I just do this 5, it's just gonna do 5 times, okay? Same thing, okay? So I think it's so far so good, okay? So I hope there isn't any questions as of now. So the next topic that I want to discuss regarding list is the indexing and slicing. So as we saw indexing and slicing in strings, it's just the same thing in list as well. So given a particular list LST of 0 is going to give you the first element, right? First item, okay? And then LST of -4 is again going to give you the first item as well in this particular list because the length of this particular list is 4. So negative of 4 corresponds to the first element, that is the 0th index of the list. So that's why we have 796 being returned again. So just exactly the same thing that we saw in strings, okay? Exactly the same thing. I repeat that again, exactly the same. Both forward indexing and backward indexing works, okay? And then slicing works the same way as in strings. So if I want to fetch the first two elements, what I do is like LST. If you don't specify the start index, it's gonna be default by 0, and then you specify the end index. So if I give 2, it's just gonna go from 0 and 1. It doesn't take the index 2, right? So we have 796 comma 7, and then the same thing slicing. I'm just using a step of 2, 796, and then it skips the second item of the list and then picks the third one, Billie Jean. Okay, quite simple, right? So here I just want to give you a clarification regarding the step when you slice, okay? So we last week when we saw if an index is not in the not in the range of the length of the string or a list, we get an index error. But when we saw slicing never returns an error, right? So, but there is one condition when like slicing does throw an error, but you won't get to this particular thing often because let's say for example, if you define a step of 2, you know what value you get. So by default, the step value is 1, right? So remember that you can't input a step of 0. Okay, that doesn't really make sense, right? So if you just input a step of 0, what you're literally trying to do is like you're just trying to stay there, right? So either it has to be 1 or -1, 2 or -2, or whichever way the way you choose, right? But it can't be 0. Okay, just remember the step of a slicing can never be 0. If you do that, it's just going to throw in a value error. So the error is thrown as value error because of the value that you input there, right? So we will see more about how to handle these errors when we see exception handling. But as of now, remember, step of slicing can never ever be 0. Okay, remember that. So now let's get into list methods. Okay, so similar to string, we have so many methods for list as well. Make sure you know each one of them because list is one of the important data structures in Python, and each time you write a Python program, you will be using list, okay, at least 99% of the time. So let's do the list methods on this particular list: 7967, Byzantine, and true. These are the 4 items we have. And then, so these are the various list methods that are available to us. So it isn't as much as strings, but still these methods are really handy, okay? So let's see the first method, append. So what append literally does is it just adds an item to the end of your list. So let's say, for example, if I want to add an item called winter of type string to this particular list, what I do is like list.append, and then I just input the value, okay? Then the object, okay? It's quite simple, right? So now you could see like the winter item is being added to the list. So here you need to note something. So whenever I tried something on a string, so let me quickly do a simple method on string here. Let's say I have apple, and I just do a string method on this. Let's say I do the uppercase. So now we just converted the lowercase to uppercase, but when I just see the variable sample again, it's still in lowercase, right? So now what I just did was like list.append of winter, but I didn't assign it to any variable, right? But still, when I just try to see what's inside the variable list lst, you could see like winter has been already added without being assigning to any variable. So this is because of the property called mutability. So list comes under the type mutable objects, and strings, numbers are immutable. Okay, so we will see what exactly a mutable and immutable object is at the end of this lecture. But as of now, just remember, you shouldn't assign to a variable the list methods that you implement on. Okay, so let me show you what happens exactly when you assign to a variable. So if I just do like result lst.append of winter. So before that, let me just this again, just to make sure we don't keep on appending values. So now no error with respect to the program, okay? But what the result variable is going to throw is it doesn't have any value, so it is literally equal to none. We will see none about like the next lecture or the lecture after, but as of now, remember, when you try to assign to a variable, when you do a list method, no value is going to be assigned to the variable that you're assigning, okay? We will see about the mutable and immutable. That will help you to understand better, but as of now, remember, don't do that, okay? So it's just gonna be this one, and then like you could see like the winter is being added to this list, okay? So this is how an append method works. Hope it's clear, okay? So let me delete this, and then the next method that I want to discuss is the extend. So extend is just similar to a concatenation of list. So what exactly what you're trying to do here is let's say for example we have a list 1 2 3 4, and we already have a list, right? This one right here. If I just do like lst dot extend of lst1, you could see like both these lists have been concatenated together, right? So the thing about that you need to note here is like when you concatenate to list, you need to assign to a variable, but when you use the list methods, you do not assign to any variable. Okay, it's kind of like automatically does the assignment. Okay, so I just did like lst dot extend of lst1, and I didn't assign it to any variable at all. The left hand side you could see, and then like if I just see lst, oops, I haven't executed. Okay, you could see like the new values have been added to this list. Quite simple, right? So the next method is count. Count is just simple. So lst of count, you just input the value that you really want to count. So I just do here like 2, and it returns 0. But you could see like we have a 2 here in our list. So this is because the 2 that I input here is of type string, and the 2 that I have in my list of is of type integer. Okay, so that's the reason why you have a count of 0. Okay, so make sure you don't fall to this particular trap. Okay, so this is going to return a value of 1 because this 2 is of type integer, and the value that you want to count here is an integer as well. But here in this case I want to count 2 of type string. Okay, I hope it's clear. So the next one is insert method. So insert is quite simple, right? So the name itself says like you want to insert something. So what you just want to do is like you just need to input the index value and the value that want to insert in that particular index. Okay, so we have a list, okay, with these values. Let's say for example, if I want to insert the value Velvi at the index 2. So what you just do is like list lst dot insert, and then you just input the index value and then the value that you want to insert. So once you execute that, you could see you have the value being added. Quite simple, right? Okay, so the next method is pop. So pop is just kind of like it just pops out that particular element. Okay, so what you need to do is like you need to input the index value. Okay, so whatever value is in that particular index is going to be removed from our list. So let's say for example, we have this particular list right here, and then let's say if I want to remove the value true, so true as an index value of 0 1 2 3 4. So I just do like lst dot pop of 4. Okay, so it's just gonna return the value that it throws out, and then if I just see the list now, you could see like there isn't a value true because that value has been popped out of the list. And then the next method is remove. So remove is just same as pop, but the key difference here is in pop you input the index value, and remove you input the value itself. Okay, so we have the list here. Let's say for example, I want to remove the value winter. So there are two ways that I could do. I could just do like lst dot pop of 0 1 2 3 4. Okay, if not, I could just do lst dot remove of winter. Directly you could just input the value itself, and then if you can see the list, so no winter, right? Quite simple. So the other two methods that I want to discuss are sort and reverse. So it's quite simple. So lst1 has the set of items, okay, and then it's just do lst dot sort. You know sort, right? So the default sort method just returns or just kind of like makes the list in an ascending order. Okay, so once you do that, you could see like this particular list has turned into this list being sorted out. Okay, so there are some complex things that you could do with sort, like you could just input key reverse. Okay, but I just want to discuss about uh, inputting these parameter values once we see functions, so that you'll have a better idea about like what's a keyword argument is. So that will give you a better understanding of how to do these operations. So as of now, let's go with the basic sort method of the list. Sorts the list in ascending order. Okay, so the key thing that you should note here is, like, let's say for example you have a compound list like LST we have here. So if I just try to run the sort method on this, it's going to throw an error. This is because we have both strings and then integers in this particular list, right? So Python is trying to sort a string and an integer, but it doesn't, it really can't sort, right? So because like we have uh, data of different types here, so sort methods doesn't work in these cases. Okay, so just remember this. Okay, for the other method is reverse. So reverse is quite simple, right? So it just reverses the list, right? Instead of from front to back, and then it just makes the list from back to front. So let's just do this. So we have a list 1, 1, 2, 3, 32, 100, 3, 2, 3. So I just run this. Okay. So now you could see like this particular list has turned into this particular list. This is because I just reversed the list. So simple, right? So other thing that I wanna say is like, you remember slicing. So where we kind of like slice like particular values using forward step, backward step. Okay, so we are gonna use like a step value of -1 in order to reverse a list or a string. Okay, so I think we already did this in string. So let me quickly show you how to do this in lists as well. It's same. Okay, so just do that means like start from the beginning, go till the end. Okay, with a step of -1. So it's just gonna return the value being reversed. Okay, so we had our list in this particular order, and then I just do this. Okay, so now the list is being sorted back as it was previously. Okay, so this is another way that you could reverse a list or a string. Okay, but the thing that you need to remember here is like, if you're trying to use this particular method of doing this particular way, you need to assign it to a variable. So because this isn't a method, right, a list method, so you have to use a variable assignment in order to store these results. Okay, that's the case with any mutable object, and list is an example of mutable object. Okay, I hope it's clear. So now what is this mutable and immutable object? So let's have a discussion about this one. So according to the Python documentation, a mutable object can change their value but keep their ID. Okay, so return the identity of an object. This is an integer. This is the definition of the ID. Okay, so this is an integer which is guaranteed to be unique and constant for this object during its lifetime. Okay, lifetime. Two objects with overlapping lifetimes may have the same ID value. Mhm. See Python implementation detail. This is the address of the object in memory. And then let's quickly go through the definition of immutable as well. An object with a fixed value. Immutable objects include numbers, strings, and tuples. Such an object cannot be altered. A new object has to be created if a different value has to be stored. They play an important role in places where a constant hash value is needed, for example, as a key in a dictionary. Okay, so we saw string, now we saw list. String is an example of immutable object. Okay, so what it really means is, let me quickly run over through the definition of immutable and then we'll go to the immutable one. Let's say, for example, I have a string. Okay, so hello world. So if I want to get the first item or the first character of the string, I just do text of index 0, right? So just returns me the value h. Quite simple, right? So let's say, for example, if I want to replace this h, let's say b, okay? So what I'm trying to do is like text of 0 is h. I'm just trying to assign the value b. Okay, so you could see like Python returns an error of type error. String object does not support item assignment. So this is because string is an immutable object. So according to the definition of immutability, an object with a fixed values, okay, such an object cannot be altered. Okay, just let me just quickly highlight this. Okay, so always remember, an immutable object can ever be altered at all. So that's the reason when you're trying to alter this text, okay, Python throws an error. This is because strings are immutable. Okay, so I hope it's clear, right? So this is an example of immutable object. So we will be seeing about tuples maybe at the end of this lecture or at the next lecture. So at that time you'll have a better idea. At that time we will discuss more about this mutable and immutable objects. So now, as of now, uh, from where we left, okay, so this string cannot be altered because strings are immutable. Please remember this. Okay, but this leads to a question: since lists are mutable, can I change the value of list? Of course you could. So let me show you an example of that. So before that, let me show you a PDF where we could see the proper explanation of mutability. So let's say we have a list 1, 2, 3, 4, and list B apple, orange, pie. So how are these lists being stored in memory? Okay, so just please consider this as a memory block. Please consider. Okay, so let's say this memory block corresponds to variable A and this memory block corresponds to variable B. So because you created two variables, each one of them is going to have different blocks, right? So let's say understand how do we understand mutability. Let's say we have only one string, only one list. Okay, 1, 2, 3, 4. And what I do here is, let me do B equal A. So now what Python really does is, instead of creating a separate memory block, these two variables are going to point at the same memory block itself. Okay, so this leads to the thing like when you make a change in one list, it is going to reflect in the other list. So let me quickly show you what it really means. Let's say, for example, we have a list 1, 2, 3, 4, and I append 23 to this. Okay, so far so good. And what I now do is like lst of 2, lst2 equal lst1. That is, I'm just assigning the value of lst1 to lst2, and lst2 has the same value as lst1 now. So now what I do is like I just remove the value 1 from this particular list, lst1, and I see lst1 has no more 1, right? So it used to be 1, 2, 3, 4, 23. Now it's 2, 3, 4, 23. So if I see the value of lst2, it doesn't have 1 as well. It's just exactly the same thing as lst1. So this is because, as we just saw, both these lists share the same memory space. So since it share the same memory space, the changes you make, okay, is also being affected in the other variable. So it's just kind of like, how could I explain it in a better way? Let me quickly think. Okay, so let's say, for example, you might have the same guy could have like several nicknames, right? So his mom could call him Randy, his brother could call him like Rand or some other random name. Okay, so all name corresponds to the same guy. in that case. Similarly, all variable names that you assign that are being assigned corresponds to the same memory space if we just assign a list to another variable. So this is the reason changes made in one particular list is being affected in the other. So even if you make a change in LST2, it is going to affect LST1 as well. So let me do a quick extend. So now LST2 is, and then LST1 is same as LST2. This is because changes made in one list is going to affect the other one. Okay, quite simple, right? Please remember this. Always know what you're doing when you're operating with lists. So these are the small things that people really miss out when they learn Python. They understand lists, they know what are the list method available, but they might be getting stuck in these kind of traps where they would have assigned a list to another variable and they might operate on that variable, and then finally they could see like the other variable is being affected as well. So please avoid these things. Okay, so let's see how to avoid these scenarios. What you could literally do is like you could just use the copy method. So there is a method called copy. What you just do is like lst1.copy and you assign this to lst2. So by assigning this way, what you really do is you just create two different memory blocks, or you create a new memory block for the variable lst2. Okay, so now we have a lst1 has these values and lst2 has the same values as well. So let's say, for example, if I just change the index value 2 in lst1 to orange, so now you could see like the 4 has turned into orange here, but lst2 has the same value 4, right? So this shows like both these variables doesn't share the same memory space, so that's why changes made in one hasn't affected the other one. Okay, hope you're clear up to this point. So the other way that you could avoid this situation is you just use slicing. So what you just do is like LST1 and then you just slice it. Okay, so you don't specify the start index, you don't specify the end index, you don't specify the step. That means collect all the list items and then you just assign it to the other variable. So now I just reversed LST1. So LST1 has this particular value, LST2 remains the same. Okay, so this is because again LST1 and LST2 doesn't share the same memory space. Both of them have their own memory space in storage, so that's the reason why the changes made in one hasn't affected the other. Okay, I hope it's clear as of now. So also the other thing that I wanna stress here is you could see like I just changed an item in a list using this particular method. Okay, so I just did like lst1 of 2 equal orange. Item assignment is being supported in list. Okay, so if I had did the same thing in string as we saw previously, it throws an error. So I again repeat that is because strings are immutable. Okay, from the definition of immutability we saw objects that cannot be altered at all. So strings can be altered. So that's the reason why Python throws an error. But lists are mutable. Okay, mutable means kind of like can be changed, right? So that's the reason why item assignment is being supported by list. So I hope it's clear. Yeah. So the next thing that I want to quickly run over is list of lists. So we just saw like a list could have like various item, etc., etc. A list could contain a list itself. Okay, so that's an interesting thing to do, right? So see see a outer list here being highlighted in green now, and then these are the inner lists that we have. Okay, so this is a separate list, this is another list, this is another list. All these three lists are inside this parent list maybe. Okay, so now indexing, slicing, everything works the same, but you just need to have a little bit of practice, I would say. So let's say now let us do some indexing and slicing on this list of list thing. So a of 0 is going to give you the first list here. So this is because a is just the list of list, right? So the first item in this list of list is a list itself. Okay, so a of 0 gives us a separate list. Similarly, a of -1 would give you 7, 8, 9. So let's say if I want to access the value 2 through indexing, how do I do is just again simple. Okay, so a of 0, I know 2 is in the first list of the items, right? So I just get those 1, 1, 2, 3, and then 2 is the second item of this particular list. So I just do this. Okay, so now we get to the value 2 through indexing. I hope it's clear. Okay, so let me just repeat it again. So I'm trying to access the value 2. So what I do is like a of 0 gives me the first list, and then in this list 2 is the second element, that is it has an index value of 1. So that's the reason why I do a of 0. It's since it's a list, again I could just do indexing, right? Of 1 gives me 2. Quite simple, right? So let me break down this. Okay, so now B is a list. So if I wanna access the value 2, what would I do? Now it's quite simple, right? P of 1 is 2. So now let us join these two uh, operations that we did into a single one. So that leads us to a of 0 of 1. So we just eliminated the process of assigning to a variable and then getting the required value through that interim process. So it's quite simple, right? I hope there isn't any question now on this. So similarly, slicing works the same way. Okay, let's say for example I want to slice out the values 7 and 8. So either I could do like 0, 1, 2, or I could do -1 because this is the last list. And then I just needed the first two items of this particular list, right? So it's quite simple, right? 7 and 8. So we got 7 and 8 as we wanted through slicing. So let me just slice directly from list A. So A of 2 gives us the first two items. So in this case, it's going to return the first two list. 1, 2, 3, 4, 5, 6. Okay, quite simple. Right, I hope it's clear up till now. So we just saw a list of lists. It can get quite confusing at some times, but I would say like with some clear practice, it's going to be all okay. I think that's one of the uh, biggest traps I would say in Python. Like everything seems absolutely clear. Like when I was learning Python, when I read about lists at the first time, I thought like, okay, list seems quite simple. Okay, but when I started working, that's when I learned a lot about list. Okay, so when should I use list? When should I use tuples, which we see later? So you need to practice a lot. That's the only way you will have a clear understanding of what exactly a list could potentially do. Okay, so what I want to say further is let me just do a compound list again. So in this case, let me do of all types that we saw. 1, 2, 4, a list. So v is list. Of course, don't use the variable name v, but I'm just using because I have no explanation to name something properly. Okay, so this is again a compound list. We have a integer, a string, a boolean, a list, finally a float. Okay, so now let's say for example I want to access the value banana. I just do like, okay, so banana is in this particular list. So this list is 0, 1, 2, 3 as index value of 3 or negative 2, right? Negative 1, negative 2. Let me do negative 2. And then banana is again the last item of this particular list. So that means I could use negative indexing again. Okay. So the other way that in which you could do is do 3 of negative 1, again banana, or you could do 3 of 2 banana, negative 2, negative 2, again banana. So we just saw like how do we access the same value banana through a combination of forward and backward indexing, right? So you could choose whichever you want, but sometimes, like let's say for example, you always want to access the last item of list. So at the time, it's better to use negative indexing. So if you want to access the first item, it's always easier if you use like just zero. Okay, like these kind of things like you will learn through practice. So which one to use, which one not to use. Okay, so what else I want to discuss? So we just saw the various methods of this. Okay, let me tell you one more thing that we could do in this. So list is mutable, right? So we saw above how do we change a value using indexing, using the index value, right? Since this is mutable, I could do these kind of things. Before that, let me quickly show what we have in this particular list. So LST has 7967, Velvi, Billie Jean 1234. Okay, so let's say for example I just want to replace the index 2 with orange. So Velvi is going to be replaced with orange. So that's done. So we have the value orange in here. So we just replace value using indexing. So similarly you could replace value using slicing as well. So let's see how do we do that. Oops. Okay, I slice the first two items, and then let me do hello. So you could see like we assign a value of list. This is because when you slice a list, you're always going to get a list. Okay, so whenever you index, you're always going to get that particular item, right? So that might be a list or a tuple or a string or a number, etc., etc. But when you slice a list, you're always going to get of type list. Okay, so that's the reason why you need to assign a list when you try to replace value using slicing. So you could see like a list of first two items like 796 and 7 have been replaced with hello world. Okay, so this is another way that we could alter values in this. So here you just replace two values with two values, but you could go beyond that. So here you could see like we had the list values hello world, orange, and other stuffs. And then like I just took the first two values, that is sliced the first two values, and then replaced it with four values. Okay, a list containing four values, and then Python just did that. Okay, so instead of having hello world here, so we have like me, comma, some, comma, coffee. So the length of the list has potentially increased, Okay, so this is another way that you could do item assignment in list. So this is because lists are mutable. You can't do the same thing in strings because strings are immutable. Okay, I hope it's clear now. So let me give you a quick recap of what we saw today. So we just saw how to create list, okay, compound types, and then an empty list, and then various operations that are related to list, the length, concatenation, multiplying with an integer. We saw how to index and slice in list, and then we saw step value cannot be zero, and then the list methods append, extend, count, insert, pop, remove, sort, and reverse. About mutable and immutable object, let me just repeat this again because this is the most important part of this video. Okay, mutable objects are the one that can be changed or altered. Okay, so an immutable is the one that cannot be changed at all. Okay, so string, number, tuples, these are examples of immutable. Their values cannot be altered at any cost, but mutable object can be altered. Also, item assignment is not being supported in immutable object. This is because, as we just read, their values cannot be altered. So that's the reason why item assignment is not being supported. Okay, so the other important thing that you need to know about mutable objects is, let's say you have a mutable object, here in this case it's a list, and then you assign that to another variable b. Okay, so now both these variables just point to the same memory space. So the changes that you make in A or B is going to be reflected in the other variable as well. Okay, so that's a key point that you need to understand. So we just saw example of how those things happens, and how do you avoid this scenario. If you want to copy a variable, you just use the copy method to do that. So by this way, the new variable that you create has a separate memory space. You could do the same thing using slicing as well. Okay, so and then finally we saw list of list, and then how do we use slicing and indexing on these type of variables as well. So I hope it's clear now. So I would like to end this video right here. I thought of doing tuples, but I just want to end it here because to give you some time to go through this, practice over it. Okay, so once we have a better understanding of list, I think tuples are really simple, and then we will see dictionaries, and then we will see the difference between list, tuples, and dictionaries, and learn when to use what. That's a really key important thing that you should know, when to use what. Okay, so final thing. So I discussed about append, copy, count, extend, index, insert, pop, remove, reverse, sort. So the only thing that is left is clear. Okay, so these are the values in this list. If you just do clear, as the name suggests, it just clears the list. Okay, so that was the only method that I left, so I just did that as well. So practice over these methods, practice over the operations, compare list with strings, compare strings with list, compare string operations and list operations, and see like what are the operations that we have in common. Okay, keep practicing, guys. Python is a really key thing for data science right now, so one must really know it. So people might think like the more packages that you know, you're good at Python. I wouldn't really agree that. The more you know at the granular level, I think that's the really key thing to understanding Python programming language, or any programming language in that case. Okay, so keep practicing, guys. So until then, goodbye from Anirudh. So goodbye.